In this video, we will learn how we can calculate the sum of two vectors. Suppose we have a vector which is A and a vector which is B. So what will be the general thought of drawing these two vectors? Here given is the angle between the vector A and B is alpha. So how we can draw it? At first we have to draw, then calculate. So we can draw like that. This vector is A, and from the ending point we have to draw the vector B, and the angle between two vectors is alpha. This figure is totally wrong. This is the wrong picture. But why? Because whenever we are given two vectors A and B and the angle between them, we have to imagine, or we have to consider that the vectors A and B have the same starting point. Here the vector A, the starting point of the vector A is this, and the starting point of the vector B is the end point of the vector A, and this thing will not valid. Okay, so what will be the correct picture? I am drawing this right now. Here I am choosing arbitrarily the vectors A and B. Okay, so this is the vector which is A vector, and now I am drawing the vector B. This is the vector B, and the angle between these two vectors A and B is alpha. This is the correct drawing. Now we have to calculate the sum of these two vectors A and B. How we can do that? To calculate the sum, we have to draw a clone of the B vector at the ending point of the A vector. Okay, so like that. I'm just drawing roughly here. This is the B vector again, right? Now we have to join these two points. Okay, we are joining these 2 points, and we should name this properly. This point is O, this point is A, and this point is B. Okay, this point is D, and okay, that's it for now. Now we have drawn this figure. Now what will be the sum of the vector A and B? The sum of the vector A and B will be the line from the O to the point this capital B. So we are drawing this. Geometrically, this is the sum. I am denoting this vector with the vector C. This is the direction, this is the direction, and this is the direction, right? Excellent. Now we have to calculate the magnitude of C, and we have to calculate the direction of C. Let the angle between this vector A and C is theta, right? Okay. Now we are extending the vector A, OA this line to some extent, and we will draw perpendicular on this line from the point B. Let's draw it. Okay, and this point will be E. Now, as this angle is alpha, so angle BAE will be alpha as well. So this angle is alpha. Fine. Now, we have to calculate the C vector. Now, from the theory of Pythagoras, we can write for the triangle OEB, for OEB is OB square. Please attention that I am not writing the vector, I am writing the magnitude only, and we are calculating the magnitude of C here. OB square equals to OE square plus BE square, right? Now, OE, what is OE? OE is OA plus AE. We can write this. So, OA plus AE whole square plus BE square. Okay. Now, we have to expand this. Okay. So, OA square plus 2 into OA into AE plus AE square plus BE square. Okay. Now, this is the thing. Now, what we can write is that OA square plus AE square plus BE square. We are writing this two first. Plus 2 into OA into, we can write AB into AE divided by AB. Here AB and AB will cancel out and we get 2 into OA into AE. Okay. Now we have to pay close attention to this part. AE square plus BE square. What does it denote? AE square plus BE square, it denotes AB square, right? For this triangle AEB. So OA square plus AB square plus 2 into OA into AB into here. For the triangle AEB, AE divided by AB, AE divided by AB will be cos alpha. So here I am writing AE divided by AB equals to cos alpha. So here we can write cos alpha. Cos alpha. So now we will denote this OA, AB and this OB by the vector notation, and remember once again we will write the magnitude only. So OB squared, that means C square, according to our picture OB equals to C square equals to a square plus b square plus 2ab cos alpha. So now what will be the value of c? So c equals to root over a square plus b square plus 2ab cos alpha. Excellent. We have successfully calculated the magnitude of the vector, the resultant vector, which is c. So this is the magnitude of the resultant vector. Now how about the direction? Remember, we have denoted the angle between the vector a and c by theta. We will use this thing. So now for the triangle OEB, okay, again for triangle OEB, this triangle, we have to calculate the tan theta. So what is the tan theta? So tan theta equals to is BE divided by OE. So tan theta will be BE divided by OE. Okay, now we have to calculate this. Okay, so what we can do is AB for the BE part, AB into BE divided by AB. We can write this, and for this part OE, we can write OA plus AE, which we have done earlier in this part as well when we were dealing with the OE square. Okay, excellent. Now we have to calculate and the terms by the vector AB and the angle alpha, which are given to us. So equals to AB into BE divided by AB OA plus, here is AE, we can do the same thing as the top, AB into AE divided by AB. Okay, cool. Now we have to express these terms in the form of AB and alpha. So equals to AB. What is AB? AB means the B vector, right? This is the B vector. So AB equals to B. BE divided by AB. What is this mean? BE divided by AB. BE, this length BE divided by AB. So BE divided by AB will be sine alpha, right? For this triangle AEB. Okay, so B into sine alpha, then divided by OA, this is the A vector, plus, not the A vector, the magnitude of the A vector, plus AB, this means the B, magnitude of the B vector, into AE divided by AB. What is AE divided by AB is cos alpha. So cos alpha. So the tan theta equals to this. So we have successfully calculated the resultant vector's magnitude, which is c equals to root over of a square plus b square plus 2ab cos alpha, and the direction with the help of the tan theta, right? So we can easily calculate the theta from the above equation. Or so the theta equals to tan inverse b sine alpha divided by a plus b cos alpha, right? So we have calculated the total configuration, the direction and the magnitude of the vector c. So what does this mean? It means that if we want to calculate the sum of the vector a and b, then just stand on the point O and go stand on the point O, and from the a vector make an angle of theta, which value is this tan inverse b sine alpha divided by a plus b cos alpha. Make angle of theta and work the amount which is denoted by the c, that is root over of a square plus b square plus 2ab cos alpha. If you do that, then you will find the vector c, which is equals to the vector sum of the vector a and b. So that's it for now. Catch you later.